First off, so I get a lot of questions around why in the world do you host a space agriculture conference, and the next speaker is really the reason for it. I think it was in 2020, kind of during COVID. Me and a colleague of mine got to have a fascinating conversation with Mr. Ralph Fritsche, who is the NASA Space Crop Production and Exploration Food Systems Project Manager. Pretty cool job title. He filled us in on kind of the future of how NASA's thinking about this long-term sustainability. Got us really excited. That's why we launched the conference. So I kind of always jokingly tell Ralph that he's the father of this conference. But I want to welcome Ralph to the stage here, and we're going to have a little Q&A. So Ralph, good to see you as always.
Hi, Andrew. How are you doing?
Well,
Thank you
besides
for
this
this
blizzard,
opportunity. It's a real honor to follow both Marshall and Barb, two people that I really look up to and have learned a lot from over the past several years. When you see how they're looking at, leveraging their prior expertise, which come from different backgrounds, but applying it towards the same goal, infusing a deep knowledge of spaceflight history as well as a desire to make a difference both terrestrially and enabling us to complete our mission successfully. It's just exciting times. I remember 15 years ago, we were trying to figure out how would we get people interested, commercial investment to be able to do something in the space environment. And now it's like people are just knocking down our doors to try to be able to work towards that goal. So it's just great to be here and appreciate the opportunity.
well, likewise, I'm glad you're here. And actually, that kind of leads me to my first question, Ralph. Is I think you've been with NASA for quite a while now. How has kind of the industry changed? And can you talk a little bit? Like I said, this is a mix between academia, government, and industry. So, talk about that investment that's coming into the space industry and how the collaboration with NASA and those three sectors are kind of coming together.
It's an interesting time because as I sit and try to look at the changing landscape, there's a few things that I notice, and that is in the past, we were so focused, as Marshall kind of implied, on the technology and the hardware systems and developing that. We historically had considered the food system to be something that was readily well understood for the durations and the distances we were flying. We had ready access to low Earth orbit in cases when we had historically the shuttle. That was something that they could bring up what they needed, take it with them, station longer stays. We have resupply. When you start talking about going beyond that, though, now we start trying to figure out what does that really mean to us. So NASA had our arms around the whole story. Now that we start talking about exploration missions, it's obvious that there's so much involved. The costs are considerable, and we really had to ensure that there was a commercial viability associated with low Earth orbit so that we could hand that off to people to know that we would have ready access to low Earth orbit before we were able to really move beyond that. And so now we've come to this threshold where there's definitely interest in the commercial sector for low Earth orbit. I think from a research perspective, there's always been the interest to have a platform in space to be able to conduct fundamental science and fundamental research. So academia was just really looking for more opportunities. And I think now when we start talking about commercial low Earth orbit destinations, those opportunities will only expand. When I start talking about getting beyond the Earth's magnetic field and into that higher radiation environment and partial gravity environment aspects, now there's other areas of research. So I think we're really in a golden era as long as we can keep pushing this ball forward and actually be successful in our attempts to get to the moon and then reach out to Mars.
Mm-hmm. Well, that's great. I think I and a lot of probably the attendees here have been following along, fascinated with the Artemis mission, and we're going to have a permanent settlement on the moon in 5-10 years, whatever it comes out to be. But can you talk a little bit about the vision? How are we going to sustain that as we start having this permanent settlements, on Moon, Mars, and I guess beyond?
So I think it's important to realize that the roadmaps that we have probably they go out to the end of the 2030s. And at that point, we're still focusing more on the near term. We're focusing on how
Mhm.
do I set up some basic infrastructure on the surface of the moon to be able to set up the foundation for a permanent or a semi-permanent outpost. So things like rovers, habitation modules, things like that are what are being talked about now. And I think in all those cases, we're not yet looking at how do I sustain a continuous presence? I think that's going to be the next chapter in the book. But what we have to do is to develop the the research opportunities that enable us to demonstrate how will we be sustainable? How can I start to begin to cut that cord from Earth? Because as Marshall alluded to, we can't necessarily afford to continually bring everything. So bioregenerative life support system is the only way we're going to be able to really make this a permanent stay, whether that be on the moon or Mars. But right
Mhm.
now, the focus is still on addressing some of the more near-term challenges. So it's a challenge. I am continually torn between trying to lay out the foundational ideas that will lead us to that bioregenerative permanent outpost on the moon, as well as addressing some of the near term challenges that we have to circumvent so we can even consider getting there. Um,
Mhm.
I don't think that the plans that we have for permanent sustainability are developed yet. I think they're still somewhat notional. I think that when we develop our interim architecture, what's being discussed now, there's always an eye to do that and look towards the future to make sure that everything that we send to the moon or send to Mars is not going to be obsolete and have to be continually replaced. We're going to have to leverage on that hardware and those capabilities and adapt them and advance them, not being something that we dispose of and replace, but continually upgrade and accelerate. So it's going to be a challenging time when it comes to food and nutrition. I think that, historically, we tend to not focus on that because it's not necessarily the exciting thing. But one of the things that I look at that keeps me focused is I tend to look on the history of exploration, especially over the past 150 years with polar exploration to the Arctic and Antarctic. And I see how important the food system was to either making or breaking those expeditions. So we recognize that food is important within the agency, but maintaining the spotlight on it in an environment where we're still trying to develop all the hardware infrastructure and all those technical challenges is something that we constantly have to strive to remind people that food is the first line of defense for crew health and performance. And so it's a real challenge, but it's something that we enjoy and look forward to each and every day.
Absolutely. I think the story of NASA is like, there's often questions around the investment in NASA space exploration. And I think one of the things that I like to imagine and how I frame it up is that, solving challenges for space solve challenges that we face on Earth. So I think if you go back to, what Dr. Ray Wheeler did with hydroponics, the long history of kind of the tech transfer that's come out of NASA. But I guess, as we push this industry forward for the next 30 years and beyond, how do you think this story of agriculture, space agriculture, is going to have direct impacts on kind of how we think about agriculture on the planet and the sustainability issues that we're facing here?
So I really think that we're also at a time now with the issues with terrestrial food insecurity and sustainability that it's no longer just NASA leading the way and trying
Mhm.
to infuse technology back to the terrestrial applications. I think that NASA is learning a lot from the work that's being done here on Earth. You can look no further than how controlled environment agriculture has taken off. There's a lot of similarity with the concepts behind controlled environment agriculture and what we need to do with space flight. There's also the fact that with climate change, we have companies out there now that are looking to see how can they breed crops that will do better in harsher environments that would subject them to stresses that would normally negatively affect crops that were maybe more traditional. So not necessarily looking at GMO editing at this point, but just looking at what is in that larger database and how can they go and
Mhm.
breed for this type of environment. Those are things that we're going to look to take to spaceflight. And then there's also the science and technology associated with GMO crops. Now that has, more of an issue in terms of regulatory approval, things like that. But as that gets more and more maturely developed and approved for certain applications, we will look to leverage that as well. We're all about trying to grow as much edible food within the small volumes that we're going to have initially. And so
Mhm.
anything that, is an impediment to that, like extra roots and shoots and stems that aren't edible, if that's something that we can engineer that out at the expense of what we can consume, that's a positive thing. So I think you're seeing climate change and the whole idea of sustainability driving this engine even without space being involved, and the two therefore are working symbiotically to really try to solve and tackle some of the problems that are on Earth that are also going to affect us in space. So I think it's a real opportune time, because I don't think space flight in and of itself would generate enough momentum to solve some of these challenges.
Yeah. Agreed completely. All right. Well, we are running behind on time, so I have a ton of questions, but this is going to be the last question. I know you're a pragmatist. I know that, but we have a lot of student groups that are coming on. So, I think a lot of people here are really just interested in the future. So, we have the 30-year roadmap or the 20-year roadmap or whatever it is lined out. But like, let's just dream a little bit, Ralph. What's your long-term vision? What are my kids and grandkids? How is this going to be impacting? Where's this industry going?
So I tend to really align well with Marshall. I would like to see that vision come into play. I'm looking for, a successful bioregenerative outpost on the moon. It's a permanent base that we've actually found commercial rationale for being there. The population on the moon takes off. What we do is we use the moon as an analog for what we set up on the surface of Mars. Exploration takes place on Mars, and we start developing a permanent outpost there. And I think what you're going to see is in the ability to be able to get to that point, when I'm there and I look back, we will have, discovered things and invented technologies that we can't even necessarily, comprehend today. Not that they're going to be so technically advanced, but there's going to be things that we never had to really develop or apply that all of a sudden we're going to know about and learn about, and that's going to change life on Earth and hopefully make for, the population of the Earth, Moon, and Mars a better place to be.
Yeah. Well, what a great note to end on. Ralph, as always, it's fascinating to talk to you, and I applaud and thanks for all that you've done for the conference and for the industry at large.
All right, thank you, and hopefully we'll be able to be there in person next year.
Yes, I hope so. So thanks, Ralph.